Okay, this is part two of the tutorial for doing a modal analysis or natural frequency analysis on this assembly. In part one, we use the Explore mode, which utilizes the real-time GPU solver to get a quick and dirty result, as you see over here. And we calculated the first 6 modes and the frequencies, as you can see in this chart. Now, I mentioned to you in part one that in Explore mode, we assume that parts are bonded together wherever they touch, as you can see over here. Okay. Um, Now, in reality, this may not be the case, and you may want to apply a more sophisticated or refined control for contact or connections between bodies. And this is what we're going to do in part two. So to do that, click here to switch to Analyze mode. In Analyze mode, we're using the CPU-based Ansys Mechanical Solver under the hood. Now you'll notice that your fixed supports and your mass that you specified in the previous setup carries through, so you don't have to do it again. But what we do want to do is review the contact and modify these as needed. Okay, so first thing we can do is double click on the tree here to expose the contact review or contact setup tool. This shows you by means of face highlighting all the areas where bodies are connected together, and the default connection type is bonded or glued, as you can see here. Now let's focus our attention on the connections in this area between the strap, the tube, and that back plate. Okay, so what we can do is we can go ahead and hover over here, and this shows you the contact pair. If you click on it, it selects that. It shows you the contact between the strap and that back plate. Okay. So by default, this is bonded, but we want to say that there should be no contact, so they should be allowed to separate from each other. So we're going to click here to exclude this from contact and turn that into a prevented contact. Okay. Now we're going to do the same for the strap and the tube, but here we want to be more selective. Instead of selecting all these faces, we're going to click here and select no grouping to be able to specify the contact at the individual face level. So I'm going to select this spherical marker and this one, and I'm going to click here to exclude these from contact detection. Okay. Now I'm going to hit escape 2 times to dismiss the heads up display. And if you look under contact, I have 2 new contacts. If I double click, it shows me my prevented contact between those bodies, which looks good. And if I double click here, it shows me the prevented contact between these 2 bodies. The change in the color is basically indicated by the fact that this contact group is 2 contact pairs, hence it's a group, whereas this one is just a single contact pair. Okay, now we do have to find some way to connect this strap to this green plate. So we're going to use a joint to do that. So double click here to select that loop, and then go in and turn on the joint tool. Click here to turn on the secondary selection, and double click here. We're going to use a fixed joint and click the check mark. This is just one way to specify the connection between those 2 locations. So hit escape once to exit that specific condition, and then we're going to do the same thing on this side. So double click here, click on this icon to turn on the secondary selection, double click here, and click the check mark. Okay. Now we could do the same in this location, but for the purpose of time, we're not going to do that. And we're basically all set. Another thing I want to point out is in Analyze mode, you can go beyond 6 modes. So I can set it to 7, 8, whatever I want, but we're just going to go with the default 6. Okay, there we go. Now I'm ready to go. I just need to click Solve. Now I want to point out that in Analyze mode, this takes a little bit longer because number one, we're running on a CPU, and number two, we're running a higher fidelity solution. So we're going to do a background mesh, and we're going to run our traditional CPU-based Ansys Mechanical Solver. So what you're losing in speed, you're gaining in terms of fidelity, accuracy, and more physics. Now, when the green line around the SID down at the bottom goes halfway around, you can visualize the mesh. To visualize the mesh, click here, and you'll see what this mesh looks like. Now, of course, you can refine the mesh by clicking on local mesh fidelity or changing the global fidelity, but we're going to do that in a different tutorial. Okay, so you can inspect the mesh any way you want. If this mesh is not satisfactory, you can pause the simulation or wait for it to run. As you can see, it's already finished running. We have the green line all the way across, and then apply a different mesh fidelity later on. Okay. So here we have it. You see mode 1, mode 2, all the way through mode 6. If I animate this, you'll see what this looks like. And you can clearly see how, in this case, the strap is actually not physically connected to that back plate. It pulls away and it allows it to penetrate. So this actually underestimates the stiffness perhaps, but it is a more conservative approach than perhaps assuming everything is bonded, which is not the case in real life. Okay, so I'm going to turn my mesh off so we can see it a little bit better. Let's take a look at a different mode. So let's take a look at mode number 2. I just have to wait a second for the animations to show up. And here you can see how if I switch to this view, you can see how it pulls away from the strap due to that local contact that we specify. Okay, so that's pretty much it. You can cycle through the different modes as we did before and see what the results are in terms of the mode shapes and the mode frequencies. So that's it. This is a simple modal analysis or natural frequency analysis in Ansys Discovery using both the Explore and Analyze modes. We hope you enjoyed this video, and we encourage you to look at all the other tutorial videos available out there. Thank you very much.